When an atom's electrons are in an unstable arrangement, they will bond with other unstable atoms in order to rearrange their electrons and become more stable. They do this in order to get an octet, a full valence shell of electrons.
Since metals have fewer valence electrons to begin with, they always prefer to give away their electrons. When they lose electrons, they become more stable and they become positively charged. This means that they have now formed a positive ion. We call that a cation. Since nonmetals have more valence electrons to start off, they are already closer to having an octet, and they're already closer to being stable. So they want to hold on to their electrons very tightly. They're not going to let anyone come and steal away an electron. This aspect of nonmetals, holding those electrons so tightly, this is called electronegativity. Nonmetals have a high electronegativity value because they hold their electrons very tightly. They don't want to give them up. But metals have a very low electronegativity values. They don't need the electrons, they'd rather give them away anyway. Nonmetals have high electronegativity values, metals have low electronegativity values. Instead of giving away electrons, nonmetals go hunting for more electrons. They want to gain enough electrons to get to their octet. When an atom gains electrons, it becomes negatively charged. This means it has formed a negative ion, and that's called an anion.
When a metal and nonmetal interact with one another, they form ionic bonds. Since the metal atom is positive and the nonmetal atom is negative, their charges attract one another, so they stick together, forming a new chemical compound. When two nonmetal atoms interact, they form covalent bonds. Since both atoms are greedy for the electrons, but both atoms still need to gain more electrons in order to be stable, the two nonmetals will actually share their electrons with one another. This sharing forms bonds that hold the atoms together, forming another kind of chemical compound. But what happens when two metal atoms need to become more stable? They both want to get rid of their valence electrons, but there's no nonmetals to come around and pick up the mess and take those extra electrons. So they just lose them anyway. Metal atoms give off their electrons no matter what because they are so desperate to become more stable. But if there are only other metals around, they need to help each other out. So the metal atoms play a kind of ping-pong game with the electrons. When one metal spits off its electrons, the other catches them. But instead of holding on to them like nonmetals do, it spits it right back. So the two metal atoms are passing the electrons back and forth constantly. This is happening so fast, and it happens so much that the atoms end up feeling like they don't have any electrons at all. So all of the metal atoms end up more stable, and in the process, they form another type of bond. These are called metallic bonds. Since no one wants the electrons, they just end up floating back and forth very rapidly in the space in between all of the metal atoms. This floating mess of electrons is called the sea of mobile electrons, meaning that there is a constant flow of electrons moving all around the metal atoms, but never really staying attached to any of them. This flow is what gives metals all of their important properties.
In metals, the electrons are free to move about. The metal atoms virtually become positive ions and are attracted to the electrons between them. The electrons are like a gas that fills the spaces between the atomic ions, holding them together. All metals are shiny. Most look silver because they reflect all wavelengths. The photons, or lumps of light, hit the free-floating electrons, which vibrate, producing a matching photon we see as a reflection. Electrons move fast and carry large amounts of kinetic energy. This is how heat is conducted from a hot spot to cooler regions. It would be more random than this. The free electrons make metals good conductors of heat and electricity. The only exception is diamond, a good conductor of heat, but not electricity. The electron blanket allows the metal to be worked into different shapes. If the electrons were fixed in position, the metal would not yield as easily as this. Under a load, the ocean of electrons can move easily, allowing the atoms to rearrange themselves. To prevent the atoms moving as easily, different sized atoms can be added to hold the layers in place. This way, iron can be strengthened by adding carbon to produce steel. Metals can be made more rigid by alloying with elements from the middle of the periodic table. A bronze cannon is made of copper and tin.